execution of Spark applications. So as part of this execution of Spark application, we are going through the DAG schedulings and the task scheduling in the worker nodes, the what worker node is do. So let's start this part. So before going to this lecture, if you watch my previous lecture, we learn about action and transformation. So in Spark, so when we start the Spark, we create a SparkContext object, and this context run internally run jobs method. This call pass to the scheduler. The scheduler runs as part of driver, and it driver has the two components, DAG scheduler and task scheduler. So as part of DAG scheduler breaks job into the direct acyclic graphs of stages. So if you see, this is a stage of direct acyclic graph in the DAG scheduler. The task scheduler is responsible submitting for shuffling on result tasks from each stage to the cluster. The DAG scheduler is intelligent enough to skip stages for computing RDD that have been precise earlier in the same application. Okay, so DAG scheduler consider data locally when requesting placement preference of task. A task that acts upon RDD partition residing in the HDFS will have placement reference of data nodes host in particular RDD. If RDD is a cache in memory, then the task will place in the executor storing the RDD partition process in the locally, since it's in the cache. The task scheduler, so if you see the example about task scheduler, so it's convert all the DAG into launch task via the cluster manager. So task scheduler receive list of tasks and match them executor running for the application. Taking placement and preference into account, the tasks are then assigned to the free executor for execution. So tasks will assign to each executor. The executor are assigned tasks the following preference. So it has some preference for assigning. First it will check process local task, then it will go for that same node tasks, then it will so multiple the node combination of node become a rack, so it will go for local racks, and if it is not that, then arbitrary non-local task. So these are preference of the execution of task. Assigned tasks are launched through the another component called scheduler backend. The executor also report back status in the driver program. If the task fail, is resubmit the task scheduling to another executor. So the task status will be maintained by scheduler backend. Before execution task, the executor makes sure the jar file and dependency are up to date. Usually these are cached from the previous run. Next task code is deserialized and it receives part of launcher message. Finally, the task code is executed on the same JVM executor. The result of serialized and sent back to executor, which forward to driver as a status message updates. So if you see, this is the Spark, how the Spark application is running. So first one is a driver. We are submitting from the driver program. It will create a Spark session, then a SparkContext, and then the reading file, then filter and map. So when we do the Sparks, so first it will go to the cluster manager, and cluster manager will check the navigates how much resource we required, and same time it will check. So cluster manager will keep on checking with the worker nodes, and worker nodes has the task to execute, and same time it's sending back to driver, and driver when the Spark is there, then it will make the DAG scheduler. So DAG scheduler first will create RDD, then RDD to convert into task, and the task scheduler then it will be launched to schedules, and based on the preference it will execute. So please like and subscribe my channel, and so I can create the valuable videos. Thank you for watching.